Okay, so why do we care? What do these do? What happens when they come together? We're going to start talking about compounds. So compounds are when you have atoms that bond together or combine. So when elements combine, and in chemistry, we call that a bond when they stick together. Okay, so there's actually two main types of bonding. There could be ionic bonding or covalent bonding. Okay, so what is an ionic bond? It's something that is a bond between what we call ions. Okay, so ions are things with charges. So ions, so like positive or negatively charged ions, they attract each other. That's called an electrostatic attraction. Ions attract. Anything that's a positive and negative charge attracting is called an electrostatic attraction. Electrostatic. Oh, I already said the word attract, right? So positive and negative ions attract each other. Now, positive and negative ions, those do actually have names. The positive thing is called a cation. I remember that because all cats have paws. Cations are positive, and negative ones are called anions. So essentially, if something is positively charged, that means it has more protons than electrons. And if something is negatively charged, that means it has more electrons than protons. And anything that has opposite charges are going to attract. They can also bond through what's called a covalent bond. And this is when they share their electrons. This is usually when a nonmetal bonds to another nonmetal. So this is where we need to know where those metals are and where those nonmetals are. Okay, so there are some, I mentioned this word diatomic in the last video. There are 7 specific elements that when they are by themselves, they form diatomic molecules, or there's 2 of them bonded together. We have them marked here on the periodic table: hydrogen, and then NOF, and then ClBrI. They make like this little 7 over here, and hydrogen. So you do have a phrase to remember these 7. It's I have no bright or clever friends. I know they're not in order, but that is a mnemonic to kind of remember which ones those are. But they're actually 2 bonded together. There are a couple that do more than 2. Phosphorus, when it's by itself, likes to be P4. Sulfur likes to be S8. You don't really have to know those 2. I would tell you that. But these diatomic ones are kind of important to know. So essentially, these ones are all a nonmetal bonded to a nonmetal. These would be considered covalent bonds, and these ones occur naturally. Okay, so we're going to move on to what a chemical formula is, what it means, how you interpret it. Essentially, what it does is it represents a molecule. That's a molecule. And what does it tell you? Well, it tells you the number of atoms of each element that are in it. Each element. Okay, so the subscript, the little number at the bottom, equals the number of atoms. So we're going to write a couple chemical formulas here. These are pretty easy to start off with. It says a phosphorus sulfur compound that is responsible for the ignition of so-called strike anywhere matches has 4 phosphorus atoms. So phosphorus is P, so it would be a little subscript 4, and 3 sulfur atoms. So then I would write S and a little 3. It says per molecule. So if they're bonded together, you write them as a word like this, P4S3. Okay, so I'm going to do this next one, ethyl alcohol. The alcohol of alcoholic beverages has 1 oxygen atom, 2 carbons, and 6 hydrogens. So technically, does not matter what order you put these in. If you just want to list them in the order that they are in, that's fine. Usually, carbon is listed first, and then hydrogen, and then oxygen. That's just kind of an organic thing to do. But like I said, it doesn't technically matter what order you put them in. So I would go C, 2 carbon atoms, H, what does that say, 6, and O. You do not have to put the 1. 1 is understood, so you don't need to put a little subscript 1 there. All right, do C really quick and then check your answer. Okay, it says this is, Freon 11. That was in automobile air conditioners. And part of the problem, we had an ozone issue. Has 1 carbon, so carbon, don't write the 1. 3 chlorines and 1 fluorine. right? So nothing like that. Now, again, this is where it's important to make sure that you don't capitalize everything. You use lowercase when you need to. This L should be lowercase, okay? And then this is going to be your formula for free on 11. Okay, so other representations of molecular structure. We just talked about the chemical formula. This just tells you the number of atoms, right? That's all it says. Number of atoms only. There's a whole bunch of other ways to draw and represent molecules that can actually show you how they're bonded or what it is in 3 dimensions. So this shows how we're bonded, a structural formula. We'll be drawing lots of those. This one is, oh, sorry, that's this D down here, is how we draw it on paper in 3D. So molecules are actually 3-dimensional, of course. It would look like this, but I can't really draw this in 3 dimensions. So this is what you would draw in 3D if you wanted to draw the molecule. And then there's also a condensed structural formula. It kind of tells you how it's put together. And we'll talk about carbon and how we know what's bonded to it and stuff later. But this is a little bit more descriptive than just C4 or CH4O. This actually tells me the carbon has 3 hydrogens on it and then an OH. Describes how it's put together. Okay, so you're going to see multiple of these as we go. Molecular formula is what we're going to focus on for the rest of this. So I have an example. It says, write the molecular formula for each compound. The condensed structural formula is given. So what I gave you is a structural formula that explains how it is laid out. I want you to make it into a molecular formula. So I essentially want you to condense it. So try that really quick and check your answers. So this is what you should have gotten. The order, again, does not particularly matter. If you have them reversed, that's totally okay. This one down here, I want to talk about for a second. These parentheses are like parentheses in math. If you have a number outside of the parentheses, it's called like a coefficient. It would distribute in. So this little 3 down here means I have 3 of the things in parentheses. So technically, this would be C3H9.